Hi, my name is Jong Yoon, and I'm a PhD student of School of Building Construction in Georgia Tech. What I'm going to talk about today is blockchain-based information sharing, a new opportunity for the construction supply chain. I have divided my presentation into four parts. First, the introduction of the background and problem statement of this research. Second, the literature reviews regarding the construction supply chain management and trust and blockchain applications in the construction industry. Third, hypothetical scenarios of the blockchain applied construction supply chain and validation of them with professional interviews. Finally, the contribution of this research and future research directions. The diagram describes one of the main issues of the construction supply chain. The information flow in the supply chain is critical for facilitating decision making, accelerating the schedule, reducing cost, and enhancing the final quality of the project. However, the information flow in the supply chain is not well integrated because the information may be fragmented in various stages or across numerous stakeholders. This poses a significant challenge to the information sharing and negatively impacts the cost, time, and quality of project. For example, some data could be lost or counterfeited, and the sharing information requires longer time frame than the integrated one. In this research, we will identify the root causes of the lack of information sharing in the supply chain, examine the potential of blockchain to address the issue, and provide a guideline for the future research regarding the blockchain applied construction supply chain by reviewing the relevant literature and developing hypothetical scenarios of blockchain applied construction supply chain. According to the review of literature regarding construction supply chain management, most studies have just focused on optimizing logistics with real-time information sharing. In addition, even though the studies developed various types of information sharing platforms, their full implementation has not been realized because of the lack of trust among the stakeholders. For the suppliers to willingly share their information, relationship management for establishing and promoting trust is necessary as well. Accordingly, additional studies are needed on how they can utilize the shared information for increasing project value, and enhancing trust between all the stakeholders should also be addressed. Several studies pointed out the importance of trust for the collaboration and information sharing in the construction supply chain. As you can see in this diagram, trust-based relationships among suppliers increase their willingness for sharing information and encourage the stakeholders' commitment to project values, which leads to the better performance of the project. According to the review of the literature regarding trust among the stakeholders, the studies emphasized the importance of trust for facilitating information sharing and improving the operational performance of the supply chain. If systematic methods providing a trust-enhanced environment are developed and leveraged in conjunction with the information sharing platforms, we can facilitate information sharing in the supply chain and thus lower project cost, enhance quality of projects, and shorten the project schedule. Then, how can blockchain technology do that? And what is blockchain? Blockchain is a technology that can enhance trust by enabling immutable and transparent information sharing and by providing an automatic contract execution protocol, which is called smart contract. As you can see in figure 3, in the blockchain, the data transaction history will be replicated and shared in all the nodes in the blockchain network. The participants can share their data peer-to-peer in this network. This decentralization prevents data loss and single point of failure. In addition, the data in blockchain are encrypted into a hash value, which the only authorized people can decode. And the hash value establishes a linkage between each block, which makes the blocks tamper-proof. Figure 4 describes the components of a block and the linkage. Furthermore, blockchain enables smart contract, that is a computer protocol that digitally facilitates, verifies, or enforces the negotiation or performance of a contract. To sum up, the advantages of blockchain can enhance trust to the data and information and the contract execution in the construction supply chain. Despite these clear advantages, the application of the technology in the construction industry is still in its infancy. Although some studies have investigated the potential of blockchain to improve construction industry, few studies have attempted to provide detailed scenarios for blockchain use cases. In addition, they have not yet verified the technical feasibility of the proposed ideas or validate its potential. In this research, we provide 3 specific scenarios regarding blockchain applications in the construction supply chain. Furthermore, through an expert interview, we verified the technical feasibility of the scenarios. This is the first scenario. Due to the concerns about data security and potential misuse of data, stakeholders in construction projects may be reluctant to use information sharing platforms, even though it increases both the project value and the stakeholders' profit. For example, if a general contractor manages the information sharing platform and stores all the documents when legal issues on project delay, cost, or quality arise, an unethical general contractor could potentially take advantage of or even falsify the data for their own individual interest to avoid potential liabilities. However, when you use blockchain, the documents will be immutable and the stakeholders transact the data peer-to-peer, so there is no concerns about data security and potential misuse of data. The second scenario addresses counterfeiting issue. According to the review, the construction industry is especially vulnerable to the counterfeiting, and the fundamental enabling source for the counterfeiting is information asymmetry leading to opportunistic behavior of suppliers. For example, there are two possible cases of counterfeiting in the construction supply chain. First, the subcontractor might use 4 tons of A brand and 2 tons of cheaper B brand and sell all 6 tons of panels under the guise of A brand. Second, the subcontractor may falsify the results of material test certificates because the quality of panels could not meet the qualification. If we were using a blockchain-based information sharing platform, such a situation can be prevented. In a blockchain-based platform, all the transactions of subcontractors will be recorded and shared with other stakeholders. Moreover, if the material test certificates are automatically recorded in the blockchain data storage, there is no possibility of falsifying the certificates. Furthermore, the smart contract can be used to prevent the opportunistic behaviors of suppliers. For example, if the conditions such as quality, quantity, or delivery time of products are consistent with the contract, then the cost will be paid automatically. It will encourage suppliers to be committed to the product quality and delivery punctuality, and it will prevent the opportunistic behavior of suppliers. The final scenario is about bullwhip effect. Bullwhip effect refers that a downstream demand is increasingly distorted and thus amplified as the transaction moves upstream in the supply chain. The reason is that each stakeholder in the supply chain individually forecasts and plans material requirements due to lack of information sharing among all the stakeholders. Blockchain can mitigate the bullwhip effect by enabling peer-to-peer information sharing in a trust-enhanced environment where information is tamper-proof. To validate the scenarios and technical feasibility, we conducted professional interviews. The construction professionals acknowledged that the problems described in the scenarios are prevailing and have not been addressed well, and agrees that blockchain can effectively reduce the root causes of the lack of trust and facilitate secure information sharing. Regarding the technical feasibility, the technicians agree that blockchain is the most appropriate technology to generate trust in information sharing, and it is feasible to build the system. So, as I've seen in this presentation today, the construction supply chain has a lack of information sharing which could be improved with trust among the stakeholders, and blockchain technology can enhance the trust. From the scenarios and interviews, we demonstrated the blockchain can facilitate information sharing, reduce counterfeiting, and mitigate bullwhip effect along the supply chain. To sum up the contribution of this research, the literature reviews and the hypothetical scenarios deepen the understanding of the relationship between information sharing and trust in the construction supply chain, clarify the advantages of blockchain by presenting specific scenarios regarding how it can promote trust and facilitate information sharing and therefore improve the construction supply chain, and examine the feasibility of the scenarios with professional interviews. As a result, these will provide specific direction for the future research. For the future research, we will develop a robust quantification metric for assessing trust in relationships among the stakeholders. We will apply the metric to examine whether blockchain can establish a trust-enhanced environment compared to the traditional information sharing environment. And we will also develop a systematic framework and a practical system of blockchain-based information sharing, and will validate the effectiveness of the system by applying it to case studies. That brings us to the end of my presentation. Thank you very much for your attention.